And there we go. Welcome to today's webinar, STEM Guitar. It's going to be talking about the Summer 2016 STEM Guitar Institute, and today is the fellowship kickoff webinar. We have a number of presenters today. Let me start by introducing our lead presenter, Tom Singer. Tom, will you tell us a bit about yourself and then turn it over to your colleagues?
Absolutely, Mike. Welcome, everybody. Thanks for joining us in our summer kickoff. We like to hold these early in May to get everybody started and revved up for the Summer Institute series. We'll all be attending workshops around the United States this summer, and this gives you a basis to really get a good understanding of what the whole project is about. Again, my name's Tom Singer. I hail from Sinclair Community College. I teach a mechanical engineering technology there. I'm going to go ahead and have Mike. Whoop, I'm going to go ahead and hand it over to Mike Akins and let Mike introduce himself.
Thanks, Tom. This is Mike Akins. I'm out of Butler County Community College. Been here 29 years. Been with the project from the beginning. I'll be working at the Kankakee workshop in Illinois. And thank you so much for being here today. I know this is carving out some time out of your day, but I really appreciate you being here. And I'll turn it over to Mr. Doug Hunt.
Good afternoon, everyone. Glad to be participating with the webinar, and I'm going to be with Mike at the Kankakee workshop, and I'll also be doing the Pennsbury workshop in Pennsylvania this summer. So I'm excited to be here with all this, and I'm going to turn it over to Nancy Chang.
Nancy, can you go ahead with your audio? You know what, folks, let's skip over Nancy for a moment while she reconnects. Let's go to Sean.
Okay, my name is Sean Haas. My name is Sean Haas. I'm an instructional designer at San Diego State University, and I will be joining Nancy at the Edmonds Community College build near Seattle, Washington.
And last but not least, Tim, would you also introduce
yourself?
Hi,
this is Tim Wilhelm from Kankakee Community College in Illinois. I am the token STEM guitar newbie here presenting today, so that you all don't feel like you're out of place being new to this as well. I learned about this at the NSF-ATE-PI conference in Washington, D.C., became immediately excited about it, and the first chance I had, I implemented it here at our school, and it is going on with great success. And I hope the same thing happens for you folks too.
Well, thank you very much. I see that one of our colleagues, Nancy, as a presenter, is having a little trouble connecting. So let's let her work in the background with our troubleshooter to restore that connection. And Tom, why don't we go ahead into the webinar presentation?
Absolutely. I'll be joining other instructors at the Texas A&M build, the Thomas Nelson Community College build, and also the Kennesaw State build. So I've got a full summer of guitar building activities. And as we move forward, you're going to see our webinar outline. We're going to be covering a variety of different topics today. Everything from a little bit of our history, why does it work, so that way you can kind of put the names and the faces together as you've been getting emails from a lot of the lead faculty. You'll be able to connect with our faculty team pictures, what a day in the Institute looks like, so to get you prepared for what to expect as you join us in the summer. A general overview. We just launched our brand new website redesign, and so we're going to ask Sean to talk a little bit about that. We actually are going to assign some homework, as teachers, and I know you're in the process of wrapping up the school year or just wrapped up the school year. We're going to give a little bit of homework that we'd like you to get started on before you come to the workshop and to the Institute, excuse me. And what that will allow us to do is get everybody on the same level of knowledge as we begin. We don't expect you to be a guitar player. I personally don't play, but we can build and manufacture great guitars together. what to look forward to in your classroom. Tim's going to give an interesting perspective as our resident newbie who's just gotten started, just over the last year and a half, jumped into the deep end with us here with the STEM Guitar project. And again, as you can see, we've got different Q&A stops along the way, so we'll actually be taking breaks to accomplish that. So I'll jump in just a little bit here, and then I'll hand it over to Mike to wrap up. But to give you an idea, this project's been going on since 2006. Whenever I look at this timeline, I'm amazed at how long our team has been together and has been actually building guitars. And it all started with what we had was a National Science Foundation grant on product lifecycle management. And in 2006, we were looking for a product to do this lifecycle management on, the birth to death of a product. And we went to Purdue University, which was one of our partners in the project, and Dr. Mark French said, hey, I got a guitar lab in the basement of this 100-year-old building. Would you guys like to come and see it? So Mike Akins and I walked downstairs, went down to Dr. French's lab with him, and we stood at the top of the stairs and looked around, and Mike and I looked at each other and said, we could do this. This is totally doable for us in this project. And that was the shining moment of how this project got started. It was a combination of unique events and then Dr. French planting the seed of using the guitar as a tool. And then from there, the next year, or that summer, Mike and I went to training. We then implemented actual guitar builds at our colleges that following year. And then from there, we started to build in the math and science behind it. Initially, we just used it as a build class just to get an idea of how it all went together. And then we put some of the manufacturing and the STEM components in initially. Now we're really focusing on the STEM curriculum and how that fits in a traditional classroom, not just a engineering or a technology classroom or a CTE classroom. We actually would like to see these this project move forward in traditional classrooms, but also after-school programs, boys and girls clubs. There is no limit to where and how this project can be utilized to excite students in the concept of using STEM topics. Mike, I'm going to hand it over to you to kind of wrap up and to talk a little bit about what we've been doing lately.
Okay. Well, again, as Tom had said, we attended the first Purdue Guitar Workshop back in 2006. And as we were doing this, he said that exactly the way it happened. We just kept looking at each other as we're going through this saying, this sure seems like something we can do at the school. And I'd just like to take a moment and advance the slide and give a lot of credit to Mark French, Dr. French from Purdue University. He was the brainchild of this. He really fathered this whole idea. He was using, I believe, classical guitars in a couple of his physics classes and engineering courses just to teach his the content. And I know that we know for sure he had no idea back then when Tom and I attended that workshop that we would be where we are now. He wrote 2 books. One is called Engineering the Guitar, and one is called Technology of the Guitar. The Engineering of the Guitar is more calculus-based. It is calculus-based, and Technology of the Guitar is algebra-based. At my community college, we use the technology of the guitar as a resource. But continuing on with our timeline, after I guess you could say we piloted the idea of doing these guitar builds during the PLM grant, St. Clair Community College pretty much became a manufacturing site. And that next year, we wrote the first STEM guitar grant. That very next year, we conducted 3 workshops. And the whole time this is going on, there's a continuous quality improvement happening behind the scenes. And a lot of credit goes to Doug Hunt and to the Sinclair team and a former team member, Phil Smith. the neck design alone has gone through many iterations, and Doug is on this call, and like I said, a big shout out to him because he's been a lot of the brainchild behind a lot of design changes. And as we went through the first round of funding in 2011, we conducted 6 workshops that summer. That was crazy. But my goodness, did we ever start getting a lot of people really excited. By 2012, we had 5 more workshops under our belt. And then 2013, we wrote and were funded the next, I guess you could say, follow-on grant. It's called Lead Guitars in STEM. The project seems to have been, I guess you could say, given the name, the STEM Guitar Project, while the actual NSF title is Lead Guitars in STEM. It seems to have been affectionately termed the STEM Guitar Project, and that's kind of what we call it anyhow. So in 2014, we continued through the second round of funding and another neck redesign in 2016. Down at the bottom, these are some amazing statistics, and I share the same thing with Tom. I don't look at this timeline very often. I mean, to be honest with you, this is the last time I looked at it last year, and every time I look at it, I am blown away. We've been doing this for about 10 years. And over 13,000 kits were shipped out last year from Sinclair. That's all to educators. And over 5,000 kits since 2007. This is a perfect example of overachieving college professors and high school and college teachers that have absolutely overachieved on this. Over 350 educators have attended the workshops, and there's over 45% participant implementation. So of you people that are on the phone, half of you, most likely, statistics are telling us, half of you on the phone, on the webinar, half of you will go back to your schools and implement this in some way, shape, or form. It could be simply using the activities online, or it could be, building guitars, and I hope it does morph into that. So I'm going to turn it over to Tim Wilhelm, and Tim has the best voice. I'm telling you what, this guy's got the greatest voice for radio, and I've actually heard he's got the perfect face for radio, but I don't know that. Okay, Tim, I'll give it to you.
Well, gee, thanks, Mike. This is Tim Wilhelm again, and the next slide up is about STEM Basics. This is the STEM Guitar Project, and the only way NSF, I think, would fund this is not as a build project, but we have to incorporate the science, technology, engineering, and math in there. The nice thing is, just like Mike pointed out, that Dr. French has 2 books he's written, one that's calculus-based and one that's algebra-based. You can come at this project from all different levels in covering the STEM topics. Here at our school at Kankakee Community College, where I am, I don't have access to much in the way of manufacturing equipment, nor do I have access to a CAD lab that I can use for the course. So some of the lessons that are actually quite excellent that are available on the guitarbuilding.org resource page, I'm not able to use, but I adapt and do other things. I actually have the students do a lot of work with hand tools, so we get into discussing basic history of technology, and we go into the traditional heritage tools and how to sharpen tools and things like that, and we even use spoke shaves and draw knives for carving on the bodies to shape them. But we do discuss, I introduce them to concepts of CAD and CNC and computer-aided manufacturing, and we do that more as a cognitive exercise. On the science side, there's lots of room to play with physical science and physics, and because it's my background, I spend a lot of time on electricity and magnetism. And keep in mind that the students that are going to come into this course, depending on how you structure it at your institution, if they are, if like I think Mike has this as a general elective for anyone on their campus. For me, it's an elective for occupational technology students. Some of them don't know a thing about electricity or magnetism, so this is their first introduction. And it's a real chance to show them that this can be not as hard as they thought it was, and also quite fun. And the idea I try to promote is that this STEM overview here is to expose them to things that have applications in parts of life other than building a guitar, and I can tell more about that later in another slide, but it really is a good way to show them that there is synchronicities and broad perspective here for applying, say, the concept of electricity or magnetism in other realms, and get them excited about taking other classes that you might be teaching. On the math side, for us, we're focused again mainly on algebra with freshman and sophomore community college students that are not looking to go on necessarily to a bachelor's degree. Calculus is out of the question. I'd spend a whole semester teaching what they would need to do this with a calculus basis, but the geometry and the algebra is valuable and useful and pretty easy for them to learn. The why does it work? One thing is, I think it is relatively easy to implement. Once you get administrative buy-in, it's pretty easy to go forward because you can do this at a lot of different levels. You don't even have to build. You can bring in guitars and have the students examine them, take them apart, put them together, take measurements. You can practice precision measurement. Back on the previous slide, one of the things in math that I've done, I've found students are weak on dimensional analysis, and so I have students that want to use a different fret dot than the one that was provided in the kit. They want something bigger, and so it's almost always measured in metric units and millimeters. Okay, well, what are you going to use for a drill bit? Because all we have is things measured in inches in the lab. So I teach them the basic simple process of dimensional analysis, and they learn how to translate that over to what fractional inch size drill bit do I need now, and then that's a skill they can take forward with them and go beyond. Gender neutral, I have found in my classes, I've done it 3 times now, about a third of the students are female. And to be quite honest, not to be gender biased, when I go through the rubric at the end of the semester grading the guitars, the ones the girls built typically get higher point values than the ones that the boys build. What I see is there are differences between male and female, we all know, and that shows up in the lab, but it shows up in a good way. What I find is that the guys are, oh my gosh, they're over there hacking wood off like crazy, and the girls are putting more effort into the detail and the finesse and paying attention to the aesthetics, where some of the guys are just hacking away. And the guys will look over and see what one of the girls is doing and say, oh my gosh, how are you doing that? And you find a lot of interesting male-female interaction in a very supportive and respectful way. And I've found that really quite hope engendering for the future, let's say. And we're starting with something here that all the students have an interest in. I would say that less than half of the students that have taken the 3 classes I've taught know how to play guitar, but they're all interested in guitar. And high success rate, we definitely have a good high success rate. In 3 semesters with an average of 12 students per semester, I've only had 1 student not finish their guitar, and I don't think he finished any of his courses that semester, so it wasn't just because of the STEM guitar curriculum itself. So Doug, you got anything else you can add about why this works?
You did an excellent job covering all the bases. Thank you.
And Tim, I have to concur. The female component of the guitar class, I also have between 20 and 30% female attendees in our open enrollment class. And so the idea is that you're right. When we go through the rubrics, the detail-oriented aspect really does shine out. And this year, when I was teaching one of the local high school classes, the female students, their guitars graded significantly higher than all of the male students. They had the top scores in the class. Doug?
Yeah. So, in continuing the discussion of why it works, um, there is an important piece of this is project-based learning and the idea that this is a long-term project to build the guitar, that there are little breakout units that you can study and kind of go off on a side trip for a class period or two and then come back and regroup and work on the guitars some more. And in that spirit of collaboration and what Tim did a nice job of mentioning is the way male and female students positively interact with one another in the lab setting. That extends to the collaboration between the students as they do some problem solving. Even within the last couple of days, my own high school students working on building guitars, and about 20% of the class roughly being female, and the positive interactions with watching them help one another with put the strings on. And once the girls understood how to put the strings on, and the guys are going through and breaking strings off and hand fisting things, and how do you do this, and them kind of coming over and saying, no, you need to do this a little bit differently, and slow down with this and be a little more careful, and that attention to detail thing, and that appeal that was mentioned on the previous slide. Everybody knows somebody that plays the guitar. They've got somebody in their family. They've got a neighbor down the street. There was that friend in high school or college. And so the guitar is extremely relatable, and it's that relatable aspect of the guitar that helps contribute to that appeal for a project on the surface that then that opens the door for us and lets us in to be able to bring in other mathematic and science topics and engineering technology topics that they might not otherwise have necessarily volunteered to sign up for a course that dealt with those things, but the guitar is the hook. And then you get this confidence that comes along as the students are excited about seeing the guitar come together. And oh yeah, I built that. There was a picture a couple slides back that had a student and he was kissing his guitar neck. And was on the timeline slide, and that picture sums it up. The other thing that happens is you get community interest and involvement. We've got a group of guitars that just got finished today. Sent a picture off, and I did not contact the local newspaper, but I am friends with one of the reporters, and he sent me an email. Hey, if you'll identify the students, we'd love to run this in the newspaper. Before I'd even had a chance to email it to him and offer that up. And so there's that interest and involvement at the community level. I understand that some schools are interested in, in some communities, there are members that step forward and want to participate, whether it's somebody that's a guitar teacher or a music store owner, or somebody wants to be a benefactor and that kind of thing. Those things come up too. So you want to capitalize, especially in the first couple of years when it's extremely new, on the publicity that this will generate when you implement this. It's not, switching gears, talking about the cost, it's not terribly expensive to get started and to get going with this. It's typically $2,000. If you have nothing at all, you're going to have to spend about $2,500 maybe in tools and equipment for a lab to get started up. And it can be sustainable through a number of different methods of, you take some of the guitars and you auction them off as a fundraiser, you participate in manufacturing and contribute in some way to the supply chain that we have. And there are things you can do to be creative about making fundraisers to be able to generate some income. And then you're going to find out in the later slides later in the presentation about opportunities to earn things that you can put towards your program also. So it's not going to be a big hit up front. The other thing is, I would say on that, it's possible to get started very, very small and build this over a couple of years. The kind of tools and things that I have now that I'm using, I didn't have the first and second, even third year that I did this. It took a while to acquire and accumulate things to get to the point where people might come in today and say, wow, look at all the stuff that you've got. The other topic that I want to cover at this point is to discuss, shifting gears entirely, is curriculum alignment. In the course of the week-long workshop and institute, you'll have an opportunity to look at some of the lesson plans that are on the website. You can look at them even now if you want to. And you'll be also challenged with coming up with a lesson plan of your own. And something that's on everybody's mind is curriculum alignment. standards, 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 because we're all getting beat over the head and ingrained with things need to be aligned to standards. In terms of what our project offers and what we encourage for folks to do, we won't attempt in any way to align to an individual set of state standards, because with 50 states, and we've got implementation in like 38 or 41 states at this point, we just can't address each state's unique standards. But we can work with national standards, and two that we choose to go with are the Common Core standards and the Next Gen Science standards. And for the math standards for Common Core, we can get into that and take a look. A lot of folks are intimidated at first, but once you get into the PDF file and you look and you see the standards and you recognize, hey, there are things that on a Next Gen Science I can pull out from my lesson plan to be able to demonstrate. And once you go through that in the course of the week-long workshop, you'll be able to also do that pretty comfortably, I would expect, with your state standards as well. So there are some core activities that we've got that are aligned to these standards, as well as, like I said, some individual activities that you may come up with on your own that you can do the alignment with once you've seen some of the things in the week-long institute. An example of what this looks like is a section out of one of the sample lesson plans. We have a standard template that we use, and that will give you the blank template at the week-long institute when we talk about that lesson plan. And here is a completed one that shows some Common Core standards from math pulled out for a particular activity. And so you can find these at the end of one of the lesson plans. And it is basically a matter of what are we covering, and then going identifying things to pull out of the long list that fit and match up. At this point, I'm going to go ahead and advance to the next slide and turn this over to Tom on expectations of participants.
Thank you, Doug. And this summer, there are some expectations of the participation component. But the nice thing is that with the expectations also comes rewards. This summer, as part of the Institute, you're going to get started on at least one modular learning activity. And we specifically term it as a modular learning activity because we don't set a timeline. If it's a 1 day, a 1 week, a 1 month activity, you can design it for your specific classroom need. This allows you to take your knowledge that you'll gain over the week and internalize it and develop a activity that you can use directly in your classroom. We encourage you to test it and to share it on our website. We provide the templates, as Doug has mentioned already, so all you need to do is just kind of follow the structure that we've developed, and it is actually quite easy to add those modular learning activities up to our website. Implementation of the core modular learning activities. So the core modular learning activities are 12 activities that our team has developed. Since you've all been to guitarbuilding.org, you've seen the guitar about halfway to 2/3 of the way down our page on our homepage. And those are all clickable links to the modular learning activities that apply to specific areas of the guitar itself. And so some of the activities are designed for middle school, early high school. Some are designed for high school, some are designed for college. And what we're going to ask you to do is implement 2 of those activities. Now, we also have built Kia quizzes that go with it. And so the concept of using Kia, and Kia is an online quizzing software that you'll have a license to. And so what that allows us to do is collect the national data of pre-post learning data from your classroom that we're able then to show the National Science Foundation, see the to recognize the learning gains that we're seeing across the country in the classrooms that are implementing. The core modular learning activities, as I mentioned, have that Kia component. It's automatically scored for you. You can utilize that in your grading matrix that you already have set up for the classroom. and you could even upload your own personal quizzes into the Kia software for use. Both implementations items are required, and at that point you receive what we term as a $400 guitar bucks. And it's truly a gift certificate to the STEM Guitar storefront. Now, the STEM Guitar storefront is set up as Doug has alluded to, is a storefront for us for sustainability purposes. At Sinclair, I know that Mike also mentioned this, at Sinclair we manufacture guitar kits. Last year we did over 1,300 guitar kits that went out to students and faculty around the United States. Many of the parts and pieces in those guitar kits are actually made by other schools. And so we are developing this unique educational supply chain, and I love to write checks to schools that basically provide us the quality parts that we're then able to then share with the rest of the nation. Now, at the next step is when you complete a year of implementation, there's also funding available to provide that completion component, or funding that we provide you once you totally complete our survey matrix. So you get a direct fellowship package during the summer. And so in the summer, you'll receive a $300 cash stipend for participating in the week-long event. You'll also receive a lunch stipend, and there might be one or two locations that we will provide lunch for you, but many of the locations this year you'll receive a lunch stipend as part of that stipend when you complete that week. You'll also, as I mentioned, receive an account access to our Kia software. So not only for personal classroom use, but also for use with our core modular learning activities. You're going to receive a support package, which is valued well over $100 at the workshop. Plus, you get to build your own custom electric guitar in 5 days. Now you have to equate that this 5 days is typically what will run at either a quarter or a semester. And so each day that we're working may turn out to be a month or 3 or 4 weeks in your actual lesson plan process. So again, working through that process is important. As I mentioned, you'll receive $400 in guitar bucks once you complete the modular learning activity and having your students participate in 2 of the core activities with the Kia quizzes. And we check using the Kia quizzes as our verification of implementation to see that you've done the pre-post. You'll also have the opportunity to receive $400 in cash for completing the follow-up activities such as surveys, submission of related requirements, and proof of project implementation. So, and again, the project implementation doesn't mean that you have to build. You could implement just curriculum modules and meet that requirement of implementation. So once again, the requirement of building is one that is not necessarily a specific requirement, but is optional. Survey and data collection. So we collect the data. The data is analyzed through the University of Cincinnati Evaluation Services Center. And so what gets evaluated are the year-end surveys. There's what is known as a retrospective survey that we have both you as a faculty member and the students fill out as a retrospective survey. And that information then gets aggregated, so then we're able to provide a report to the National Science Foundation of our progress on our grant project. You'll also receive pre and post institute surveys that we administer during our week-long event. And again, the core activities, as we mentioned, the Kia also gets utilized in our evaluation process. So Mike, we've now come upon our first Q&A session. Have you noticed any questions that have been typed in our chat area that we need to answer.
Well,
Yes.
for 81 people, we're a pretty quiet group for 81 people. But the most questions were from middle school teachers, and it looks like we'll have a nice constituency of middle school educators with us this summer. But the questions were if people were implementing this at the middle school, and there are, and I can let some of the other team members address this, but you'll also be, once you go through the workshop, you'll be delighted to see that we are now carrying necks that are pre-fretted. And there was somebody on one of the questions from a K through 8 school, and we had been looking at this for a while at that age level and the dexterity required to really put a good fret job on a fretboard. So all of that to say that for you middle school folks, you're going to be delighted to see how we can do this at the K through 8 level and even at the middle school level. Those were the most questions. It was the middle school teachers, and I really appreciated that. There's a question of how to dress for the workshop. Ed, we're going to be addressing that later on in the workshop. So that's a really good question. You know, we do have bases, Dan. Dawn, I'm sorry. We do have bases on our website. I don't think we build them at the workshop. We just try to keep this a little, it's just a little too much logistics for us, if you will. Those were really most of the questions that were on there. I would encourage you folks as we move forward, type your questions down. I write them down, and I will address them, or one of the other team members will address them. If there are no other questions, I'm going to advance the slide to me. Okay. This is our team. This is the national team. Tom Singer is the co-PI, Tom Singer is the PI, and we have a couple co-PIs. Mel Cosette, myself, Mike Akins, and Debbie French, and I believe Doug Hunt are co-PIs. You met Doug, you met myself, you met Tom. Mel Cosette is out of the Materials Ed, Matt Ed, NSF Center in Edmonds, Seattle. And Debbie French just finished her doctorate at the University of Wyoming, and I think she is going to be actively employed here somewhere. There's our, you can't call him Grandpa, he's just too young, but there's the guy that fathered the project, Mark French, out of Purdue University. And there's our evaluator, Imelda, is our external evaluator at the University of Cincinnati. And Doug Hunt, out of Southern Wells High School in Indiana, good guitar builder, good guitar player. Steve Brown out of College of the Redwoods, and Scott Robbie out of Ventura. And there's Steve Wendell. Steve Wendell works with us at Sinclair Community College. Kevin Murphy helps us with some PR, and he also manages some of the workshops up at Edmonds Community College. And Sean Hawes is our IT guy, and he makes it all happen. I don't know how it's smoke and mirrors to me, Sean, but you do a great job. We just had a redo of our website, and Sean did all of that and rolled that out today. And Sean's out of the University of San Diego, I believe it is. There's Ed Uford. Ed Uford is in Washington State, and David Lake is also from Washington State. And those two guys have taken the guitar project to another level. We had them at a workshop at Edmonds Community College, and the very next year, they were not only building guitars and implementing the project, but they were putting lights in the guitars, these wild finishes. They just did a great job. They conducted their own workshops, and then after that, they got into building ukuleles. And these two guys are real champions. These two guys are what happens when you go through a workshop and you can see it and you want to do it and you like it. They're just real champions. And right in the middle is Nancy Chang, and she is another champion. She attended the workshop at Edmonds, went back to her school, and is implementing, and she's on the call, and you'll be hearing from her real soon. That's our team, and folks, I am proud to be part of it, and I am excited for you to be the beneficiaries of all the experience these folks are going to bring to you this summer. And I'm going to advance the slide. Yeah.
Yep. Real quick, I was going to say we've got a couple of members that we didn't have the photos up there. You've met one, Tim Wilhelm, and then our other new member is David Parker, who's a physics instructor out of Maine and New Hampshire area, right on the border there. So they're going to be joining us at some of the builds also this summer. So they just came on board as our newest team members.
Yeah, I think the reason our pictures aren't there, Tom, is they didn't have the criminal history report cleared yet. All these other pictures, these people are cleared, okay? So they're good ones.
Yep, I don't know.
And with that, I'm going to turn it over to Nancy.
Well, hi, everyone. Is my audio okay?
Yes.
Audio sounds good, Nancy.
Okay, great. So I'm going to talk to you about what you can be thinking about and doing to prepare between now and your Summer Institute. First, I'm going to tell you a little bit about what I do and how I got started, and then I'm going to tell you what I've learned since then about how to be really prepared when you show up at your institute, like what to wear and what to expect in the daily schedule and that sort of thing. So I attended my first guitar building workshop in 2012. I'm a high school math teacher. I had really not ever used any tools or anything. I had not worked in a shop. I don't use an electric drill. I have sons and brothers and other people who do that work for me. So I was really nervous, and I attended with my teaching partner who runs our robotics team. So she had a little more experience. But we showed up in Eastern Washington, and for our workshop, it was in August. It was 100 degrees, and you know, we turned out to be the only women in the class. And not only were the other attendees mostly, they were all men, but mostly they were all shop teachers and were really good with tools. So we felt a little intimidated. But I'll have to say that by building the guitar, I learned how to use every tool that we needed to use in the shop. And 4 years later, now I feel very confident. And Kathy, my teaching partner, and I always say, if we can build guitars, if we can teach guitar building, anyone can do it. So I hope that helps you feel a little more confident going into this if you're not a shop teacher or a construction worker. First of all, there's some homework you can be doing between now and then. Tom and others have touched on the specifics of that, but some other things you could do if you haven't already is look on the guitarbuilding.org website. Sean has been in the process of updating the site, so it's even easier to navigate now than it was a week ago. And you can see all kinds. In fact, Sean's going to be taking you on a tour of the website in a few minutes here, so I'll leave the details of that to him, but definitely you want to do that. There's a section on the website that has videos on how to build and all the different steps. It's really useful to watch at least a few of those ahead of time. We will be looking at those during the week, but the more you know ahead of time, the better. Something you could be thinking about is, what might this look like in my classroom? So that, depending on what you teach and what your background is, that could be some, very different answers to that question. And I'm going to be talking about that some more in a few minutes too. Another thing you might want to do is make sure you are very familiar with your state's learning standards for your subject area. So for me, that was Common Core Math, and just knowing how to align what I was doing with guitar building to algebra and geometry and the other things I was teaching, because that's how I'm going to sell it to my administrators, and that's how I'm justifying, cutting out a section of geometry class so that I can teach guitar building. And why is that valuable? Why is the school going to let me do that? So that was something that, having it all aligned to state standards was very, very persuasive in getting others to support me higher up. One thing that Kathy and I found helpful is setting a goal. Now, our goal was to build guitars with our students. We knew right away that we were going to do full-on implementation, actually, because it hadn't occurred to us that there was any other way to do it. And so we already had a full class of 18 students signed up for guitar building in June. We attended the workshop in August, and 2 weeks later started our first class. So we were very ambitious. We did run into a lot of snags, but we worked out everything and had in fact, our best build ever was that very first one that we did in a locker room on the back 40 of our campus. And even the district didn't really know we were back there. The principal set us up with a shop back there with borrowed tools out of a warehouse. And anyway, that's quite a story. There's a video about that on the guitarbuilding.org website if you would like to see how that looked. But some of your goals might be to simply, begin to create a workspace or start to build a shop. We had all the students involved with building our shop, and they really took ownership of it. It was a beautiful thing to see. If you're not able to build, if you don't have a workshop, another thing you can do is just integrate guitar building principles and concepts into your existing curriculum. You're a math or science teacher, there's a lot of ways you can do that. You'll have access to a full comprehensive curriculum around guitar building that covers lots of different subject areas, and you can use those lessons in your classroom and bring the guitar that you made as a starting point before, rather than implementing if that's not possible. And now this is the big question, what do I wear? What is fashionably appropriate at a guitar building workshop? Well, the first thing is it's work. You are going to be dusty and sweaty, and there's things that you will get on you like paint that don't wash off. So you want to wear something that, you don't care if it gets paint on it or dust on it. And I would wear, if you're in a hot climate, it's okay to wear shorts and a t-shirt. You want to avoid sandals. We want to wear closed-toe shoes, so like, tennis shoes and sneakers, that sort of thing. You don't really necessarily need steel-toe boots or anything to that level. And you want to be able to move around comfortably. You don't want to wear anything restrictive. And I always wear layers because some places have air conditioning that comes off and on, and sometimes we're cold and sometimes we're hot. And we move from one workspace to another. So when we're in the classroom or the computer lab, it might be cold, and walking back into the shop might be hot. Another thing is safety equipment. So if you have access to safety glasses, hearing protection, a dust mask, I would bring that. It's just better to have your own. Sometimes we have a few that you can borrow, but to be guaranteed that you're going to have some for your own purpose, your own use, I would bring your own. Okay, now we're going to talk about a typical day at the Guitar Building Institute, and Doug Hunt is going to join with me here, and we're going to just talk about what to expect when you show up. And of course, first of all, you're building your own custom guitar in 5 days. This sounds impossible because it takes at least a semester to do it with your students, but it can be done. We've done it many, many times, and you'll also be exploring the curriculum I spoke about in activities and practicing with those lessons. Doug, did you have anything you want to add at this point before we go on?
Yeah, sure. A couple things, on the previous slide as far as what to expect, and it fits with this slide too, is make sure that you stay hydrated. Especially, these are summer workshops. Most of the places where we'll be you're going to get warm, even if there's air conditioning, with some of the sanding and some of the more vigorous physical aspects on the first and second day in particular. And the first and second day tend to be the dirty days in the afternoon, with the heavy lifting on a lot of the guitar shaping and a lot of the sanding and so forth. But a typical day at an institute, we will start the mornings in the classroom, and we will do classroom activities in the morning. We'll have our lunch break, and then the afternoon is typically the time where we're in the lab working on the guitars. Like I say, Monday, Tuesday, a lot of shaping and a lot of sanding, a lot of dust, and then Tuesday, Wednesday, a lot of sanding and shaping on the necks. with the woodworking aspect of it. And then midweek, things kind of shift over. And midweek, and these are in the afternoon sessions, with some of the finesse parts of installing the frets and working with the fretwork. And then that level of finesse and detail kind of spirals tighter and tighter as we get towards the end of the week, where we're trying to hit like a bullseye with getting the guitar to play like it's supposed to. And things start out, rather crude and coarse at the beginning, and then everything kind of goes through a funnel as we go through the week. In the morning sessions, on Monday we'll fill out some paperwork so that we can give you money and be clear with the IRS about filling out, I think it's some W-9 forms that we fill out, so that we can take care of your stipend. We'll do some introductions. Some of the morning activity things that we'll do is we're going to look at the guitar pieces and do some measurements and make some comparisons among the guitar shapes. Yes, they're all manufactured. Yes, there's a little bit of variability, and we want to be able to kind of address that and go into that with our eyes open. We'll have an opportunity, Nancy was mentioning earlier, have an idea what you want this to look like. And for some of you may be chomping at the bit, and some of you may still have some questions about, well, what could this look like? And as you go through and you build the guitar, wherever you are on that spectrum is going to become even clearer as the week goes on. There will be several important opportunities where we have to kind of collaborate and chat with one another, and it's in talking through and having some discussions, things become even clearer and more concrete for people, and they have that aha moment about how they would, here's what I can do and how I can take this back to my school. And with the agenda, I think everybody's got an agenda. If not, you'll be getting an agenda before your institute, so you can see what to expect. But we go through, like Nancy said, with all the safety instructions prior to. If you have a favorite pair of safety glasses that you want to wear, by all means, as long as they're clear. Tinted ones don't work indoors very well. Clear tinted glasses that you like, by all means, bring those. I'm trying to think if there's anything else. Nancy, go ahead and fill in some gaps for me for anything I might have overlooked, please.
Yeah. Yeah, though there's also some close-up detail work, so if you need magnification, bring your reading glasses. I think you're seeing on the screen right now is a sample schedule from last year's workshop. So you'll have one of these pages for every day that tells you exactly what's going to be covered. And Doug has gone into already an overview of what's going to happen during the day. So we spend the mornings in the classroom or a computer lab. I do recommend that if you have a laptop or a tablet, you want to bring that, because not every location will have computers as you see in this picture. This was, I think, maybe in Connecticut, they had a computer lab that was fully functioning that everyone could use, but that doesn't always happen, so it's a good idea to make sure you have a way to get online. In the classroom, there's a list here of what we're going to cover, overview of the daily tasks. This is when the instructors do presentations on curriculum and implementation and different topics. This is where you will be actually going through lessons that have already been written by the team that you have access to on guitarbuilding.org website. You will also be designing a lesson yourself, your first MLA, which is a modular learning activity, which is part of the requirements for earning your stipends that Tom talked about in the beginning. You'll also be aligning tasks and activities to the state standards, which is why it's a good idea to get familiar with those before you arrive, so you're not spending time kind of figuring out where yours are and which ones apply to your subject area that you teach. Then the fun part, I think, is in the construction lab, in the workshop. And Doug has mentioned some of these things already too, as have others. There's so much that goes into building a guitar. You're going to design and contour and sand the body for so long that, I couldn't even sleep the first night. My arm ached because I hadn't done that much physical labor in a long time. But it was the next day. There's less sanding, and you'll heal. Then you can do the neck, headstock design, and fretting. We do all of that ourselves. So it's very satisfying, and that's where we can bring in a lot of math. You'll be soldering all your wiring harness and pickups. If you haven't soldered before, this is where you'll learn how to do that. And then the last step is intonation, where you put your strings on and adjust the string action and the scale length and get everything all perfectly fine-tuned. Doug, did you want to add anything to any of those?
No, you did a very nice job. Yeah.
Well, thank you, Doug. So did you. Now we would like to turn this over to Mike Akins, because we are already back to another Q&A session.
All righty. Another question and answer session, and some of these were answered as we were going through. I was watching it, and I answered a few, and I think a couple others were answered. Let me go back and look at my notes. And let me see. The question was, one of the questions was styles that we'll be building at the institutes. At the institutes, and Tom, you can certainly, or somebody can pipe in here. I know we do the single cut, the double cut, the Jazzmaster. What else?
Well, actually, a lot of our designs of the guitars, and you can, if you visit the guitarbuilding.org website and the storefront, inside the storefront you can see the 7 different designs that we produce. And so we replicate, not 100%, but closely approximate designs that you would see in a commercial setting. Again, part of the learning opportunity within the classroom is talking about copyrights, trademarks, patents. And so that way your students can get an idea of what a protected idea is and how do you protect your unique design. And so we do have guitars that replicate a Telecaster, a Stratocaster, a Les Paul, a Gibson SG. We've got a unique design that was developed by one of our local high school students that is called an Axe. And usually we send a variety of different instrument designs to each of the workshops. There is a bit of luck involved because the selection of the individual instruments is done through a lottery system, but nonetheless, each guitar is unique and different, because when you're finished customizing it, it truly is your instrument.
Yeah. Okay. Well, let me keep moving here, brother. So one of the questions was about the necks, and our necks are. Doug answered that question. Our necks are screwed on, and we don't glue them on. Someone asked about work gloves. You can bring work gloves, but I think it's going to be kind of hard to work with them. We use gloves when we're dipping or doing anything with finishes, but you'll just have to see how that works using gloves. The person, Casman, or Casme,
there's some new high performance tactile gloves that could be used for woodworking to help prevent splinters and so forth. Not a requirement. As Mike indicated, we provide the nitrile gloves for whenever you're working with finishes.
Yeah. Nancy and Doug did a really good job talking about the MLAs and the activities that you folks will be designing and developing. Here's what I would encourage you to do. This is kind of the tail end of the Q&A, so I'm just going to end with this. I would encourage you to think about what it is you teach, what it is you do for a living, what it is you teach, and how can you spin the guitar in, around, or through that. I would, if you just started thinking that way, because when you get here, when you get to the workshop, you start building the guitar in the afternoons, you'll have a little better frame of reference when it comes to developing those workshops. Okay, so if there are no other questions, and again, you can go to the website and see what designs that we have. We don't bring them all to the workshops. As Tom said, it's a bit of a lottery, and it always has worked very well for us. So having said that, I'm going to turn over to our the best surfing instructor I've ever had in my life, Sean Hawes.
Thanks, Mike. So as several team members mentioned, we just launched a new website yesterday, so I encourage you to go online, even if you've already been to the old website, and revisit our website at guitarbuilding.org. So there you'll find a ton of resources. I want to highlight a couple resources. In the About tab, you'll see the Institute page. So there's tons of resources for you to check out, including previous Institute schedules, and our current schedule will be posted on there shortly. And you'll see other links there, including surveys and MLAs, as we mentioned, that are very important. Also, if you look under the Teach tab, you'll see a few important links there, including our KIA page. So if you take a look there in advance, you'll probably be more at ease during the Institute this summer. Our modular learning activities, you can take a look at some of our MLAs on that page, and also our teaching syllabus. If you look at community, we will soon be launching a forum functionality that we're going to roll out hopefully this summer at our institutes. But for now, you can see a gallery of guitars that past participants have designed, and you can also share your guitar building photos, videos, media exposure, and press issues. Not pictured on these slides is our social media icons, but I encourage you to go on there and like our Facebook page and follow us on Twitter. And you'll see all kinds of posts coming from our team as well as instructors out there in the field. Also, if you look at downloads, if you're ever wondering where that file is or specs on something, you can probably find it in our downloads. And if you ever have any questions on the website, please click the Contact Us button, and you can send us a message and give us feedback on the website. And with that, I'm going to pass it back over to Tom for the homework.
Yeah, thank you, Sean. And one other final thing about the website, you may notice, let me slide back here real quick, that we also post updates. And so at times, like any manufacturer, there's the times that we discover that we ran into a manufacturing issue. So instead of issuing a full-blown product recall, what we do is we'll provide updates and a video fix, so how you can repair or utilize and adjust for a condition that we discover. And so we try to post those up on the website and be very upfront about whenever we discover if we run into an issue. Usually it's a very minor component, but again, we try to create it and shoot a video for that. You'll notice that our video library is quite extensive of our materials. Well, let me back this up here. So Mike and I are going to talk a little bit about guitar parts. And there's quite a few different parts of the guitar that kicks off our overall first homework assignment for you. And this particular activity has been refined many times, but ultimately there's a core set of parts that you're going to be working with, and getting the name and the terminology correct instead of, well, this thingy, well, the thingy, has a name that we utilize, because if you end up having to purchase one of those thingies, we just can't type that into the Google search line and actually find one. So in essence, we start off with the guitar body and the guitar neck are the two major components. And from there, we have other pieces of hardware that will attach to the guitar itself. The activity is found as part of our modular learning activity under our Teach tab in the MLA resource. And so utilizing some of those MLA resources, or reviewing some of the MLA resources prior to an institute, will give you a better idea of some of the directions that you can take your own MLA towards. In the lower corner, you'll see a picture of one of our guitar kits. This is, by the way, exactly how you're going to receive the guitar kit at the institute. In the lower left, you'll see the body selection lottery take place. And so each of the guitars, even though they may have the same style of shape, are each uniquely developed. And we provide both paint and stain grade. And we say stain because it's typically a clear finish where you can see the wood through it, as opposed to the paint aspect. Mike, you want to talk a little bit about the guitar part cost analysis homework that we're going to have them work on?
Yeah, when you go to the website and you go down halfway, 2/3 the way down, you'll see the diagram of the guitar. Oh, geez, I forget what activity number it is. But there's a balloon, and as you hover your cursor over it, it will be this activity. It will be called the guitar anatomy activity. And in there is this spreadsheet, and we want you all to download that, and we want you to use that just to cost out the guitar. Realizing that, there are some people on the webinar that aren't familiar with guitar. That's not a prerequisite. It's never been a prerequisite. And I would also encourage you that if that's all you're doing is wanting to build a guitar, I would just say, hey, check it, because this is inspiring teachers and students all over the place. So back here, all of these guitar components that are part of the activity are what we want you to cost out on the spreadsheet. And as you cost them out, it'll total those up. Most of us, I know I do, but most of us use this as the very first activity in our accredited guitar classes. It's a great place to kind of get started. You'll have some guitar people. You'll have some non-guitar people. You'll be surprised what the guitar people don't know, and you'll be surprised what the non-guitar people do know. It's a great exercise. We gave you a couple websites there, and there's more. But those are a few websites that we gave you, and on the spreadsheet there's a place for you to tell us where you found the information. And as we said, it's a great way to start. There is actually a Kia pre-quiz for this and a Kia post-quiz. As Nancy, I believe, mentioned, or as Tom mentioned, all of our activities have a pre and a post-quiz. That's what makes the data good for the NSF. And that's one of the things that we're having you do with these MLAs. So this is really your very first activity. So when you show up at your respective institute this summer, we would certainly anticipate that you would have this. It'd be nice if you could print it and have it printed. And then we just go through the room. We just say, hey, how much was yours? That's what I do with my students. I'll say, well, how much was yours? 300. How much was yours? 850. How much was yours? 250. Some people are being real frugal. Others are not. I don't put any limit on it, and you may want to. Another spin-off of this, somewhat serendipitous, is when they do finally get done costing their guitar, and then they see what they paid for their kit. It's a little perspective. It's still a pretty good deal. You're paying $80 for a kit, and you've costed this guitar out to cost you $1,200 or $800. So it's a good activity in that way as well. And I'm going to turn this over again to the guy that's got the best face for radio, Tim Wilhelm.
Thanks, Mike. That was a joke. Before I can talk about what to look forward to in your classroom, you kind of have to realize all of the classrooms are going to be different. So what I can share is in the recent past what I did to get my classroom going. First of all, I was blessed with some serendipity. I had in my curriculum for electrical technology, I had sort of an open course called Special Projects that we could use for anything. It's a 2-credit-hour course. Now, here's one of the things you can expect. Is put in a lot more time than what there is ECH for out there. This 2-credit-hour course is slated to run one evening a week from 5:30 to 8, and I typically do not leave the lab until 9:30 or 10 p.m. because students are still there working. So that's one thing you can expect, but what that is a sign of is enthusiasm. The other thing is you're going to want to get administrative buy-in on this in order to be successful at all. One of the things I did was talk our second in command in our administration, Dr. Boyd into being a student in my STEM guitar class. He liked it so much, and he is so supportive of it now, that for the Instructor Institute this summer, we will have four-station workbenches that weigh 600 pounds each, brand spanking new, big laminated maple tops, all because he was in the course and now he's so supportive of it. Also, you got to get the ball rolling. And what I did to get the thing started was I got started late, creating the course late in terms of the registration period. And so what I did was I made up a flyer, printed off about 100 copies, took the guitar I built during the Instructor Institute I attended with a small practice amp, and I went down to the school cafeteria at lunchtime. I plugged in the middle of everything and everybody, and I just started playing. And after I played a few riffs at the top of my lungs, I said, "Ladies and gentlemen, may I have your attention, please?" And I announced the course, and I passed out flyers all over the place, and the course was full within about 3 days. So that's how I got the ball rolling here. Some of the things focusing on the slide here, what challenges did you have to overcome? Again, setting up the lab was a lot of effort to first get it rolling. But again, like I think it was Doug pointed out, it's really not that expensive. And you can use borrowed tools. I bring in a lot of my own tools, and little by little I'm able to purchase those so I don't have to use up my own tools in the lab. And having space is an issue too. But again, if you get administrative buy-in on this, they will make space for you. Impacts from learning, I guess you would say, learning impacts. I'd like to tell a little story because this kind of relates to the learning impacts. One of my students the first semester came up to me at the end of the semester, and privately he said, "I want to thank you for saving my life." And I said, "What? What are you talking about?" And he said, I didn't know what I was going to do until I took this course. And he said, "Now that I've had this course, you've helped me decide, and this is a STEM course, I'm going on to get my bachelor's degree, and I want to be a high school physics teacher." And I'll be doggone, that's what he's doing. So that, I thought, was a good thing. That was a triumph, I would say. Other triumphs I've had, in the first semester I had a veteran who had come back from the big sandbox and had a touch, I think, of post-traumatic stress, and kind of kept to himself and didn't talk too much with the other students. And as time went on, you'll find this is another triumph you will see, is the camaraderie that develops. They all want to help each other. They all want to work together. And this guy opened up and started helping the other students. He started laughing, and at the end of the semester, he walked out of the lab with his guitar in his hand and holding it by the neck. He turned around, gave a thumbs up with the other hand, and literally did that thing you see in the movies where you jump up and kick your heels together, and walked out of the room. And to me, that was a big triumph. I've also had, as we've mentioned before, many students not play guitar, but I've had two daddy-daughter teams come in and take this. I had a lady build a guitar to give to her father, who was a guitar player, for Father's Day. She said it was the first time in her life she ever saw her father cry, and it brought them closer together. I have a lady building one now for her son, who's a guitar player, for his birthday, and he doesn't spend much time talking to her or anything, and hopefully that's going to be a bridge builder there. So in addition to all of the STEM concepts that are learned and reinforced, in addition to the technical skills that are learned, there seems to be some great emotional side to this as well. And anybody else can pipe in here with other things you've seen in your classrooms. Hello? Hello?
Yeah, we're still here. Yeah.
Oh, okay.
Yep. Yeah, we're still here, Tim.
Yeah, hi.
You have
This
to
is
just kind of
Doug here, Tim.
unmute. Yeah, go ahead, Doug, and I just thought I'd unmute here.
Yeah, I would add some anecdotal things. I had the first year I taught this, I had a student that was a chronic discipline problem, and he was, imagine your thumb and your index finger about 1/10 of an inch apart. He was that close from being expelled. It was like, if you do one more thing, you're out of here. And in the course of building the guitar, he became very, very interested in just the painting aspect of it. I've got a spray booth, and we spray with compressed air guns. and he ended up getting an after-school job at an auto body shop and came in beaming one day when he said that they let him spray primer on a fender for a repair job for a customer. And then a couple days later, he was about to jump up in the air. He couldn't contain himself that they let him actually put the color coat on top of the primer. And last I heard, that was what he was doing, was auto body work. I've had kids come through, didn't know what they wanted to do. And when they graduate, what are you doing? Oh, I want to go to such and such school and I want to study mechanical engineering. Wow, that's really cool. As far as some challenges to overcome, I hope I'm not working ahead. Am I working ahead, Tim?
Nope, I don't think so.
As far as challenges to overcome, it has been difficult to get females interested, but the ball has gotten moving on that. And each year I've got a few girls and a few girls and a few girls more as they see a girl that's a year ahead of them or a year that's the same age and say, hey, I can sign up and take that class next year. And when they see girls coming out of the class with guitars, I think that it gives them the idea that, hey, this is something I could do also. But the first couple of years, I didn't have any females taking the class, and I think it's good to have that balance, that blend of genders, even if the girls are still in the minority right now. That's really good. But that's been kind of a challenge for me to have to try to figure out how to get over.
Another good thing that I've seen come out of this is, I don't know how your mothers are, if you have elderly mothers like I do, but when she first got a computer, she was afraid to do anything because she was afraid she was going to break it. And there's a similar thing that goes on in the guitar lab with students who have not had a lot of experience working with their hands and working with tools. They're reticent to try things. And so one of my bylines in class is, I encourage courage. And I let them know, hey, it's a hunk of wood. If you break it, we can fix it. If you gouge it, we can patch it. And if you really mess it up, well, guess what? You've just changed the design, and we're going to redesign around this new interesting feature you've added, and it might even be better than you originally envisioned. So it teaches them that it's okay to try things and to experiment and be bold. And in the end, they're very pleased with the work that they've done.
So one of the biggest challenges that many times that we get asked is, how do you fund this? How does the funding model work? And each school handles it a little bit differently, or each organization handles it a little bit differently. One of the local high schools in Dayton that we work with funds it as a juniors project. So the junior engineering students come in and build at our college, but the students don't receive the guitar until they graduate. So it hangs on the wall in the lab for a full year. When they graduate, they then can take the guitar down and take it home as an incentive to complete graduation. And this is an inner city high school that does this as a graduation incentive. At another high school that I teach at, we have set it up to where it's the senior project. So it's their senior project that they work on, which is the second half of the semester. So again, it engages the seniors when they're typically checked out of school. So they know that they're going to be graded. It is both a college credit class and a high school credit class that we're able to offer for them. But nonetheless, the students are engaged completely. And just this week, I finished a week-long quick workshop with a set of alternative school students. And so the alternative school is basically the students that are aggregated from a variety of high schools that have either gotten in trouble with the law or have been expelled, and this is their last stop. And typically it is their last stop before jail in most cases. And so we worked with a group of alternative school students, and this is our third year doing this. Each year it's a unique experience, and it's an amazing transformation for the students. Many times it's their first success in mathematics. They do algebra. They realize when we present it as algebra, but they're laying out the fretboard spacing, which is another one of our modular learning activities. As Mike indicated, that was our first project, was doing the cost analysis. So they had to do research. So they had to go out and research the costs. By the way, Mike, the average in that class was over $900 was the average guitar parts cost when they went through that exercise.
Wow.
So, yeah, it was amazing. And so at the end of the week, one of the unique components is that we also bring in somebody to help teach them how to play the guitar for that week. And so they actually do a concert for their schools, home schools principals, and for their parents and significant people in their lives to again show that this is something that they've completed, that it works, that they built it, that they did all the steps to accomplish that. And what we use is one of our new kits that have the pre-made neck that they are able to paint and put together in just a week's time. And so I don't do it alone. I've got helpers. I've got lab technicians that help me with this class. But it's doable. And finding the funding, many times it's just contacting the right people or getting the right people involved as part of this process early on.
Tom, you reminded me of something too. A lot of people approach this as the students purchasing kits, and I've decided to set it up a little differently. I don't even call them kits. I call it lab supplies, and we have a laboratory fee. The laboratory fee covers the cost of the kits, for lack of a better word. And what I tell the students is I have supplies that are full of educational opportunity, and if they finish their guitar and they consume all of the supplies available in the process of that, well, those supplies no longer have any educational value, so they may as well take the guitar home. But if they do not finish it by the end of the semester, there is still educational value left in that machine and those parts in that supply pile right there, and I keep it for the lab itself. And that's one way we do it. I also don't have a textbook, so there's no textbook fee. The only fee they're paying is this lab fee for supplies.
It's a great way to handle that also. Mike, I think we've come upon our final question and answer break. We've got about 7 minutes left. We've got a couple of slides to go. And so,
okay. All righty.
Are there any
let me see.
questions that need to get answered?
There was several, but a lot of them are getting answered as we're going along here. There was a question about the anatomy, but there was let me go back here. Oh, okay, I think that was kind of answered. Mary Beth had a question. How do you fund the equipment in a public school? Do you typically have each student make a guitar, or can they work in groups? How much space is required as compared to a typical high school science classroom lab? And there's been some people weighing in on that, but I would just add that, Mary Beth, we've had science teachers, and if you are a science teacher, we've had science teachers kind of collaborate with the woodshop teacher or the tech ed teacher, where they can go down and use a lab on occasion. The toolkits that you'll see on our storefront, we put those together trying to give the most and minimal tools that you would need. Everything you need to get the job done. We didn't put a drill press in there, of course, because we're kind of hoping that you might be able to collaborate with a tech ed or a wood shop teacher or somebody there that might have a shop. And if not, we have people implementing, and Nancy's a great example, people implementing all over the country without shops. Okay.
So Christina, I think, just asked the question, are there any heavy machine requirements? Not directly. You can do this with mainly hand tools. We do suggest a drill press that does make drilling a little bit easier for some of the parts, but everything could be done with just hand equipment. In terms of the larger tools, and all the tools that we suggest are tabletop tools, so it doesn't have to be large scale. A tabletop drill press, a tabletop bandsaw, and we also suggest some sanding stations. And you'll see all this equipment at each of our institutes this summer. Some institutes have it as that we're going to be working in a wood shop where they'll have larger scale equipment. Other institutes, we're going to be in a smaller environment and not have all the woodshop amenities. But nonetheless, we ship in all the tools that we need for our institute event, and they fit in about 10 boxes. So in essence, you don't have to have a full complement of tools to accomplish a build itself.
There was another question here. As a host site, is there any specific software required for the computer lab? Not for the host site that I would see. I mean, it'd be nice if we had some CAD packages. We don't get into teaching any CAD programs, but if a host site would have AutoCAD or one of the popular ones and somebody knows and they want to design their headstock that way, that's wonderful. That's what we do at our home schools, but oftentimes sites don't have that. That is one of the activities that they design their headstock, and they can do that either just on a piece of paper and transfer it, or we can do it with a CAD system. At my school, we design the headstock with a CAD system, and then we print it, cut it out, lay it on the headstock, and we trace it off. I don't have time to cut that out with a CNC router, but that's how we handle the headstock. And there's some other questions here. They were all answered. I made a note when Tim was talking. I just wanted to reiterate something he said. I believe there's a lot of diversity on this phone call or on this webinar with regards to what we all teach. But I would say that when you get around the bench with a bunch of people and you're working on a piece of wood that eventually is going to be a guitar, and there's a really high interest of everybody, something pretty magical kind of happens. And barriers go down, conversation is very free, and to Tim's point, he said there were some victories. There are definitely emotional victories happening all through this. And we're disguising it as teaching STEM, right? Okay, I'm finished with this, Tom. I think you're taking it away here.
Yeah, I just wanted to wrap it up. We've got about 2 minutes left, so I wanted to make sure everybody that's on the webinar here, at the very end of the webinar, we're going to have a short survey, just 4 or 5 questions. Again, the data that we collect is what we use to justify to the National Science Foundation our existence. And so that's the concept of asking for a lot of survey and data information, because that's required for our continued funding development. So as a quick review, homework, if you have the opportunity to review some of the videos, there's some really excellent videos. There's some historic videos that we'll talk about at the institutes, and there's some brand new ones. The cost analysis sheet, which is the guitar anatomy and cost analysis, make sure you bring that with you, because that's a Monday morning activity. Many of the lead instructors will be sending out a link as a KIA participant. And so we'll have you actually go through a pre-post activity component. So as you get started this next week, if you're attending Texas A&M or Thomas Nelson, I'll be sending you a link as a KIA participant to do a pre-assessment for that guitar anatomy activity. What to bring? Bring some safety glasses. We usually have a few extra pairs, in case you forget it. That happens. Hearing protection, again, optional, but again, it's always a good thing to have. We again usually have some on hand, but we always make sure to remind everybody to bring some. A dust mask, especially if you have some sensitivity to that, and because the first couple of days are very dusty. And the last thing is closed-toed shoes. Always wear comfortable clothing. We're totally, I don't want to say totally informal, because that provides almost too large a variety, but basically jeans, t-shirt, shorts, t-shirt is a typical attire that we recommend joining us with. Laptop or internet device. All of our host locations will have internet available because we will have Kia quizzes that we'll be accessing online. We'll be doing some online research and development. So you will need some type of an internet device. Could be as small as a phone, could be some type of a pad device or a laptop itself. Be on time. Over the next couple of weeks, you're going to be receiving, and I say couple because the institutes actually start the first full week of June. So over the next couple of weeks, as we get ramped up here, you'll be receiving where to park, what the schedule is, any other details that you need to know as you come in. And if you do have questions, don't hesitate to ask your lead instructor, which has already contacted you as part of this process. This week at the Institute is an extremely busy week. It's an amazingly rewarding week. I know Mike can also verify we've been doing this now for about 10 years. Every year it changes how people look at instruction. Many times, whether you're a early or a late instructional faculty, meaning early career or late career, it really does provide a unique perspective in teaching and instruction. So be prepared for that because it is an amazing transformation that happens over the week. Any other final comments from our presenting team? Perfect. As I mentioned, there's going to be a survey that'll be popping up here. And if you would, go ahead and please take that survey. And I'll turn it back over to Mike Lasecki and to wrap us up.
Thanks very much, Tom. I'll just make a comment that some Macintosh computers don't launch the survey, and so what I'm going to do is put the survey link into the chat window, and then people will be able to open it from there. I'm doing that right now, Tom. Let's see if I can get it in there. If I could only remember what the keystroke was. There we go. Tom, I thought it was just an excellent presentation today. A lot of great questions for everybody. So I'm saying there was a survey now. The survey is opening in other windows, and presenters, please don't take the survey, okay? Just leave it alone on your desktop so that we don't accidentally close it for everybody. Tom, I think this officially ends the webinar today. Are we all set? It looks like we finished perfectly on time.
Absolutely, Mike. Thank you so much, and thank you everybody for attending our Summer Institute webinar to get you kicked off and hopefully jazzed for what you're going to be experiencing this summer.
Good. Friends, that officially ends our webinar. I'm going to leave the survey up, and I'll leave the system open for another 5 minutes or so, and that'll allow everybody to complete it. So thank you again. This concludes the recording of the webinar. I'm going to stop the recording now, and just to remind you all, you will get a link to the recording. Tom and my presenter colleagues, thank you very much. I'm signing off now.
Thank you, Mike.